Look at this data stream. When you build a Power Automate flow and test it against 10 records, the execution is nearly instantaneous. It creates the illusion of a robust system. But when that same automation moves to production and the data multiplies by thousands, the system chokes. The symptoms of this collapse are highly predictable. Your sequential loops slow to a crawl, the underlying API connectors hit their throttling limits and reject incoming requests. You begin seeing temporary 429 server errors. Or worse, the flow silently executes partial logic, creating duplicate records without triggering a failure alert. To build enterprise-grade Power Automate solutions, you have to stop focusing entirely on adding more actions to the canvas. You must start architecting for performance, fault tolerance, and observable state management. A successful test run in a development environment means nothing if the underlying architecture mathematically guarantees throttling under production loads. The fastest way to crash a Cloudflow is retrieving unchecked bulk data. Building an automation on a small SharePoint list forgives poor data practices, but scaling up to enterprise databases like Microsoft Dataverse exposes them immediately. This diagram illustrates the trap of nested loops. If you retrieve an unfiltered batch of 5,000 invoices and then use a secondary loop to cross-reference 20 distinct data points for each one, those two simple actions multiply exponentially. You have just forced Power Automate to process 100,000 individual API requests, guaranteeing a throttle event. You prevent this by applying an OData filter query directly inside the initial retrieval action. You push the computational burden back to the server, creating a strict barrier so that only the exact records requiring processing ever enter the flow memory. Do not confuse filtering with pagination. Enabling pagination simply forces the connector to retrieve additional pages of records when the dataset exceeds default limits. It increases your total data load. Filtering strictly reduces the baseline dataset. Once you retrieve that filtered batch, pass the array through a select data operation. This strips out all unnecessary system metadata, mapping the payload down to only the exact columns required for your logic. By combining OData filtering and the select operation, you minimize the physical size of the data payload over the wire before any iterative logic begins. Once your data is optimized, you have to process it. By default, the apply to each loop executes sequentially. Waiting for one record to finish before starting the next ensures predictable timing, but it scales terribly for bulk operations. You can accelerate this by opening the action settings and enabling concurrency control. Adjusting the degree of parallelism slider allows Power Automate to process up to 50 array items simultaneously. But as we see in this processing diagram, true parallel execution introduces a severe architectural hazard: race conditions. If two parallel threads attempt to write to the exact same shared variable at the exact same millisecond, the logic collides. Uncontrolled concurrency breaks systems with order dependencies. It creates file locks if multiple threads attempt to update the same Excel table, and it easily triggers duplicate record creation if existing record checks overlap in time. This risk compounds if you enable concurrency at the trigger level as well. Trigger concurrency and loop concurrency multiply against each other, drastically inflating your simultaneous thread count. Begin with a highly conservative parallelism value and validate your thread safety. Increasing execution speed without enforcing thread safety will reliably result in silent data corruption. As automation requirements grow, developers often build massive, monolithic flows on a single canvas. These are incredibly difficult to troubleshoot and prone to timing out, particularly when complex logic waits on long-running human approvals. To solve this, you decouple the architecture. Here, a central parent flow acts strictly as a batch controller. It retrieves the data and delegates specific tasks to specialized, isolated child flows for validation, document generation, and notifications. Child flows enforce strict typed inputs and outputs. They establish reusable business logic that multiple automations can call, and they allow you to isolate asynchronous operations, like sending an approval and immediately freeing up the parent flow to process the next record. To manage this modularity, these workflows must be built inside a Power Platform solution. Wrapping these flows inside a solution gives you access to two crucial new modules: environment variables and connection references. These components eliminate hard-coded SharePoint URLs, database pointers, and email addresses. By abstracting the configuration away from the flow logic, You can safely deploy the same solution package across development, test, and production environments without modifying the actual flows. Decoupling monolithic logic into managed solutions is the only way to build systems that are testable, reusable, and safely deployable. Even in a perfectly optimized architecture, failures will happen. You must separate transient failures, like temporary network timeouts and API throttling, from permanent failures, such as invalid data types or missing records. For transient errors, you implement fixed or exponential retry policies in the action settings, but retries require idempotency. You must generate unique transaction IDs and check for existing records so that a retried operation does not accidentally process the same invoice twice. However, retrying a permanent error is useless. It wastes API requests and delays failure notifications. Permanent failures require structural intervention. We handle this using the try-catch-finally pattern. Using Power Automate scopes and the Configure Run After setting, we create distinct execution zones. If an action inside the try block fails, the system immediately bypasses the remaining actions and drops into the catch block instead of crashing the entire flow. The try scope executes the core business logic. The catch scope activates only upon failure, capturing the specific error details, writing them to a centralized log, and alerting support. The finally scope always runs last, recording the total execution duration and resetting the final status. Structured exception handling transforms catastrophic flow crashes into observable, manageable data points that support teams can actually resolve. Look at this complete architecture for a 5,000 record batch processor. It filters data via OData at the source, controls concurrency to prevent race conditions, delegates tasks to child flows, and wraps the execution in a structured try-catch framework. This architecture must be supported by strict enterprise governance. That means using dedicated service accounts rather than individual user credentials, enforcing least privilege permissions, and adhering to strict naming conventions for every action and variable. Before deploying, you must verify your production readiness. Test with realistic data volumes, not 10 records, but 10,000. Monitor the Power Platform Admin Center to track API request consumption and verify your throttling limits. Advanced Power Automate development is not about adding more actions. It is about designing predictable, reusable, observable, and resilient automation. Mastering these architectural principles transitions your role from a flow builder to an enterprise solution architect, capable of delivering resilient, high-volume systems